Okay, hello everybody. Today we are going to do lesson 7.3 triangles, and by the end of today's lesson you are going to be able to classify triangles. The second half of my objective we'll cover tomorrow, which is finding the measurement of missing angles. First thing you have to define is you have to define what a triangle is. A triangle is a three-sided closed figure. It has to be closed. If it's not closed, it's not a triangle. And the big important thing that I want you to get out today is this second sentence, that triangles are classified by both their sides and their angles, meaning that each triangle has two names. So when I ask you to classify or to name a triangle, I'm expecting you to give me both the names that qualify for that particular triangle. So how do they get their names? The first name always comes by the angles that they have inside them. So we're going to classify by their angle. So every triangle will have one of these three names with them. The first one is an acute triangle. And an acute triangle is a triangle which all the angles are acute. All of them. Every single one. So we're going to draw the triangle that most people end up drawing. Looks like this. And you'll see, like, as you move it around, each of these angles would be underneath 90 degrees, making them all acute, and that is what an acute triangle is. The second type of triangle is an obtuse triangle, and it can only have one obtuse angle in it. The other two would be acute. So to draw this one, we'll draw our obtuse angle first. Remember, obtuse means over 180 degrees. And then if you connect the other two sides, you'll see that automatically these two angles here would be under 90 degrees. So they would be acute. So two acutes and one obtuse. The third one, the right triangle, is a triangle that has exactly one right angle. And just like the previous triangle, it will have two acutes to go along with it. So every triangle has at least two acutes in it. Really, the third angle is the one that classifies it. To draw a right triangle, start with drawing your right angle first. And then if you connect the other two sides to close the figure off, you'll see that the two other ones would always be acute. The second way to classify a triangle is by their side. So every triangle will have one of these three names attached to it as well. The first one is scalene, and a scalene triangle is a triangle with no congruent sides. And I'm going to draw two scalene triangles for you because I want to show you the different ways that they might be marked, that you might see them. The first one for a scalene triangle, you want to try really hard, the best of your abilities, to try to draw two sides that are different lengths, and then hopefully the third side is also a different length, and try to do that to the best of your ability. But the first way you would see it is a triangle with absolutely no markings in it. If there are no markings on it at all, that would be a scalene triangle. The second way a scalene triangle would be drawn is it would have markings on the sides to indicate that they're not alike. The markings I'm about to put on here are called tick marks. So I'm going to put a singular tick mark on the first side of this triangle, a double tick mark on the second side of this triangle, and a triple tick mark on the third side. And basically what this means is when you have tick marks, any of them that match means that they are congruent, meaning they have the same measure. So since these all have different markings on them, none of them would be the same. The second classification by size is an isosceles triangle. And isosceles triangles have two congruent sides, and the third side would be different. Again, I'm going to draw this two different ways. The first way you would see it is first I'm going to try to draw two lines that are the same size, and one that looks a little shorter. what you'll see is you'll see tick marks of the same number in those two sides and then nothing on the third side. So when you look at this, you say, oh, those two must be congruent to each other. The other way that you might see it is singular tick marks in the sides that are the same and then a non-matching one on the third side. Very interesting fact about the isosceles triangle that is good to keep in the back of your mind as you're solving problems later is that every isosceles triangle has two equal angles as well. The angles where the tick marks point to would be congruent. So this one and this one would be congruent. And then the one with the 2 on the other side would be the one that is different in an isosceles triangle. That always is true because that's how it would be to try to form this type of triangle. The third one is the equilateral triangle. And an equilateral triangle is a triangle in which all the sides, every single one of them, are congruent. And there's only going to be one drawing for that one. When you see an equilateral triangle, again, to the best of your ability, try to draw one where all the sides are the same length. There would be a singular tick mark in all of the sides. And interesting fact about equilateral triangle is that if all the sides are equal in length, all the angles have to be equal in measurement. Otherwise, it wouldn't be able to be formed. So again, think about the tick marks that they're pointing. If the tick marks are the same, the angles would be the same. So this angle and this angle and this angle would all be the same. Again, kind of going back to the scaling, they would all have to be different angles because all of the markings are different. The second part of the lesson for today is the triangle inequality theorem. It's a theorem that tells you what the lengths of each of the sides have to be in order for a triangle to be formed. This is always true. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if you add two sides of a triangle together, it has to be greater than the third side, otherwise it would not be able to be put together. Now, it's true, it can be any sides that you put in there, but the best way to test it is to make C your longest side. And if you do that, you'll always be able to double check and make sure that it's right if you make C your longest. So the problems here, 1 through 4, I'm asking you to tell me, can these make a triangle, yes or no? And the way that you test it is you use the triangle inequality theorem, which says that side A plus side B must be greater than C. And again, what you want to do is you want to put the largest one at C, because that will be obvious to you that it's true. So 15 is my largest, so I'm going to replace C with 15. And I'm going to put 12 and 9 for A and B. Now, it doesn't matter what order you put them in, again, because of the commutative property, because it's an addition problem. But the longest side, you want it to be C. So then you add those two on the left together. 12 plus 9 is 21. And 21 is indeed greater than 15. So because that is true, yes, this can be made into a triangle. For number 2, we're going to do the same thing. A plus B. And it has to be greater or it wouldn't open and close. Then C. And again, the way you want to handle this is you want to put the largest one in place of C. And I'll put the other two for A and B, the 16 and the 7. We're going to add those two together. 16 plus 7 is 23. And I get a statement saying that 23 is greater than 23, and that is false. That is not true, which means this one cannot create a triangle. Please pause the video. I'd like you to try numbers 3 and 4. All right, let's see how you did. For number 3, I got a false statement, so that means that cannot make a triangle. I got 19 is greater than 20. That's not true. And for number 4, I got a true statement, 75 is greater than 70, so that one is a yes. All right, the last part of today is we're going to find possible third side lengths of a triangle when we know the other two. The directions say the measure of two sides of a triangle are given. Write an inequality to represent the possible length of the third side. And we're going to use this triangle inequality theorem to do it. So the first thing we want to do is we want to come up with the lower limit. And to come up with a lower limit, what you're going to do is you're going to subtract the two numbers that are there. Then we are going to come up with the upper limit. And you're going to add the two numbers that are there. So our lower limit is 3 and our upper limit is 13. We're being asked to write an inequality. So here's how you do that. You're going to write the lower limit first, which is 3. You're going to leave a little bit of a space, and you're going to write an x, and you're going to leave a little bit of a space, and you're going to write a 13. And what that basically says is that x is in between 3 and 13. But because it is an inequality, we have to write inequality symbols, and they look like this. So if we're going to be in between, x has to be greater than 3, so the alligator is going to eat the x. And since this is the upper limit, the x has to be underneath that 13, so it's going to eat the 13 because the 13 is going to be bigger, and this is our inequality. This is called a compound inequality because you're basically doing two inequality problems in one. Take a look at number 6. Again, I want to find the lower limit. So I'm going to do 34 minus 22, which is 12. And I'm going to find the upper limit, which is 22 plus 34, which is 56. And now I can write my inequality. X needs to be between 12 and 56. And again, for the bottom or the lower limit, x needs to be greater. And for the upper limit, the 56 needs to be greater. So that would be my inequality to represent the possible third side. That's it for today. We'll pick up on the 7-3 notes tomorrow when we do the triangle sum theorem. Have a great day, everybody.